Hello everyone. In this video, I'm going to teach you how to find the nth term expression of a quadratic sequence. So stay till the end of the video and learn it. So without wasting time, let's do some math. So in the last video, we learned about sequences. We figured out how to find the nth term expression of a linear sequence, and we identified the common difference, or the difference between the two successive term is common. But in case of quadratic sequences, how do we even identify the given sequence is quadratic? So let's check that out first. Let's check with an example. It says write down the next two terms in the following quadratic sequence. So let's check what's the difference between 9 to 13. It's 4. Then 13 to 19, that is 6. 19 to 27, that's 8. So now we can clearly see that in this sequence the difference is not common, but it's 4, 6 and 8. Let's find the second difference. So 4 to 6 is 2, it's increasing by 2. 6 to 8, again it is increasing by 2. So the second difference is common. So this is an identifier. Whenever the second difference is common, the given sequence is a quadratic sequence. So the given sequence is a quadratic sequence. Now we'll figure out how to find the solution or the nth term expression of this quadratic sequence. So let's check. So there are three expression or equations that we have to remember, but before that let's mark these three. So consider this as t1. T1 is equals to 9, T2 equals to 4, and T3 is equals to 2. So we have these three expressions, that is equations, that is 2a equals to T3, then 3a plus b is equals to T2, and a plus b plus c is equals to T1. Now the question is, why are we even writing the three equations in terms of a, b and c? Because the general form of quadratic equation is ax square plus bx plus c, and we have to work out the value of a, b and c to write down the quadratic expression for this quadratic sequence. So let's try to figure it out. 2a equals to t3, that means we can write 2a equals to 2, so a is equals to 1. And now 3a plus b is equals to t2, so 3 into 1 plus b is equals to t2, that is 4. So b is equals to 4 minus 3, that's 1 again. And the last one, a plus b plus c equals to t1. So a is 1, b is 1, so we can directly substitute 1 plus c is equals to t1, that's 9. That makes c is equals to 7. So from here we can write down the nth term expression in terms of n. So nth term expression for the given quadratic sequence, that is ax square plus bx plus c. So a is 1, so we will directly write n square. B is also 1, so we will write n, and c is positive 7, so positive 7, and this is our nth term expression, n square plus n plus 7. To check, we can also check whether our answer is correct or not. So let's check. If I want to find, let's say, the fourth term, and it should come out as 27, so I'll substitute 4 here. So 4 square plus 4 plus 7, and this should result as 27. 4 square is 16 plus 4 plus 7, 16 plus 4 is 20, 20 plus 7 is 27. So when we are substituting 4, we are getting 27. That means our nth term expression is perfect and it's correct. Let's check another example. Question 2. It says, write down the next two terms in the following quadratic sequence. So again, we have to write, in this case, we have to write down the next two terms. In the previous question, we had to mention next two terms. Okay, so even in that one, we had to mention next two terms. So we already have the nth term expression. We have four terms. You can find out the fifth term and the sixth term. So let's check. Fifth term will be 5 square plus 5 plus 7. So that is going to be 25 plus 5, 30 plus 7, 37. So next term is 37. And then next to that, if you substitute 6 here, so 6 square plus 6 plus 7. So 36 plus 6 plus 7. 36 plus 6, 42 plus 7, that's 49. So the next two terms are 37 and 49. So we'll write 37 and 49 as our final answer. Let's check the next question. It says, write down the next two terms in the following quadratic sequence. So we'll remember what we did in the previous question. Just check. Negative 5 to 0. So again, it's a increasing sequence. So negative 5 to 0, it's 5. 0 to 9, again it's 9. 9 to 22, I think it's 13. Yeah, the difference is 13. Now 5 to 9, difference is 4. 9 to 13, difference is again 4. So the second difference is common. That means it's a quadratic sequence. Now let's check. So we can directly write 2a equals to 4, 3a plus b is equals to a plus b plus c equals to negative 5. So from here I'll figure out the value of a, b and c. So 2a is equals to 4, a is equals to 2, that's the first value of a, and then 3a plus b, so 3 times 2 plus b is equals to 5. So 6 plus b equals to 5, that makes b is equals to 5 minus 6, that's negative 1. And let's find out the value of c now. So a plus b, so a is 2, b is negative 1, plus c is equals to negative 5. So 1 plus c equals to negative 5. So c will be negative 6. So that's the value of c. So now we can write down the expression. So nth term expression will be 2n square minus n minus 6. So this is the nth term expression, but we have to write the next two terms. You have to write down the next two terms. So we'll do that. Let's check. Let's substitute. So we have four terms. We have to find the fifth term here and the sixth term. To find the fifth term, let's substitute 5. So 2, 5 square minus 5 minus 6. So that's 25 into 2, 50 minus 5 minus 6. 50 minus 5 is 45. 45 minus 6 is 39. So next term is 39 here, positive 39. So 39, and the next term, sixth term will be 2 into 6 square minus 6 minus 6. So 6 square is 36, 36 into 2 is 72, 72 minus 12, so that is 60. So the next term is going to be 60. The answer is 39 and 60. Let's check another question. I hope this was helpful and easy to understand. First, we have to find the value of a, b and c. So 2a is equals to t3, so a is equals to 2. 3a plus b is equals to 5, so b is equals to negative 1. Then a plus b plus c is equals to negative 5. That's how we got c equals to negative 6. We figured out the nth term expression, and then we calculated the next two terms, that is fifth term, which is 39, and sixth term, which is 60. 39 and 60 is our final answer. Let's move on to the next question. So in this question it says the nth term of a sequence 2n square plus 4n minus 1. So expression is already given to us. They are telling us to work out the 10th term of a sequence. So these types of questions are also asked in the examination, where the expression is given to you and we have to find an unknown term. So 10th term. So to find the 10th term, we have to substitute 10 in place of n. So 2 10 square plus 4 times 10 minus 1. 10 square is 100. 100 into 2 is 200 plus 40 minus 1. So that is going to be 239. So that's the 10th term, 239. 239. So this is the answer. 239 is the 10th term. I hope this is helpful. Let's check one more. It says the nth term of a sequence is n square plus 2n, and work out the first 5 terms in the sequence. First 5 terms in the sequence, that means we have to find the first term, second term, third term, fourth term, and the 5th term. So let's check. If I have to find the first term, I'll substitute 1 in place of n. So 1 square plus 2 into 1, so that is 1 plus 2, that's 3. Then second term, that's 2 square plus 2 into 2, so 4 plus 4, that is 8. Third term will be 3 square plus 2 into 3. 3 square is 9, and then 9 plus 6, that is 15. That's the third term. Then fourth term, that's 4 square plus 2 into 4. So 4 square is 16. 16 plus 8, that's 24. Fifth term, let's check the fifth term now, the last term that we have to work out. So fifth term will be 5 square plus 2, and in place of n we'll substitute 5. 5 square is 25. 5 into 2 is 10. So that's 35. So these are the first 5 terms of the given sequence: 3, 8, 15, 24, and 35. 3, 8, 15, 24, and 35, and this is the answer. We can check more questions. It says work out the formula of nth term of the quadratic sequence: 5, 11, 19, and 29. You can try this question, so consider this as a practice question. Solve question number 5, and you can just submit your answers in the comment section and tell me what's the nth term expression for question number 5. It's an increasing sequence: 5, 11, 19, and 29. So work this out and write down in the comment section. I'll tell you whether it is correct or not. Question number 6 is also same. 17 also increasing. 7th also increasing. 8th also increasing. So now this is a decreasing term, so let's check this one. Consider this as the last question, and we can wind it up. I hope this is helpful. 19 to 15, so it's decreasing by -4. 15 to 9, it is decreasing by -6. 9 to 1, it is decreasing by -8. Then -4 to -6, it is decreasing by -2. -6 to -8, it is decreasing by -2 once again. That means the difference, the common difference we are getting in the second difference. That makes it's a quadratic sequence. So again, let's write down 2a equals to -2, 3a plus b equals to -4, a plus b plus c, a plus b plus c is equals to 19. So from here we can write 2a equals to -2, so a equals to -1. Then 3a plus b is equals to -4, so 3 into -1 plus b is equals to -4. So -3 plus b is equals to -4. So b is equals to -4 plus 3, that's -1. So b is also -1. And the last one, a plus b plus c. So a is -1, b is -1, plus c is equals to 19. So c will be 19 plus 2, that's 21. So now we can write down the quadratic expression: an square So nth term will be negative n square negative n plus 21, and this will be the nth term expression. This is the final answer. I hope these questions were helpful and you learned how to find the nth term expression of a quadratic sequence. In the next video, we are going to learn how to find the nth term expression of a cubic sequence. So yeah, till then you can try these questions. Try with question number 5, and if you want to try other questions as well, you can try question 6, question 7, and question number 8. Consider this as practice questions, and if you have any queries in these questions, you can surely write it in the comment section and I'll get back to you. That's all for today's video. Bye everyone.